Hey everyone, today I wanted to have a little look at this multimeter that I've got. This is a Chauvin Arnoux C.A 5273 and it's been sent for me to use to create apprentice content for level 1, level 2 training moving forwards. This meter is just as good as most of the higher end meters that you may see, and it's important when you select a multimeter to find one of good value and good quality. Whenever I pick up a multimeter, the first thing I'll obviously do is recognise the quality of the way it's made, but also leads is a very key area. Now, the Chauvin Arnoux aren't specifically branded, so to speak, but they are manufactured to the same quality as maybe some other branded leads, maybe like Flute, for example. These are category 4 rated. I'll cover all the categories very soon, but these leads are category 4 rated, as well as this instrument. This instrument is category 4 rated to 600 volts and category 3 to 1000 volts. The point of the category is if you're working in different environments in electrical installation, for example, if you're working at the incoming point of the supply, such as the main switch room and the intake equipment, you're going to have exposure to much larger levels of voltage faults and over voltage disturbances, and you're going to want category 4 equipment in that environment. When you then go further into distribution assemblies and sub-distribution, you can then come down to category 3, and then the category 2 and 1 respectively as you come to the end on equipment itself. So this multimeter is pretty much good for any location in the electrical installation, and 600 volts for category 4. That's pretty much all you'd want to do. You wouldn't obviously test any high voltage with this. That would need a much more stronger piece of equipment. So what is it about this specific instrument that I like? Well, this is the 5273, which is not the high-end model of its range. It's probably 2 or 3 from the bottom. But it does have the display light, which took me a while to figure out how long I had to press this button down for. But it's got this vivid blue display, and from when you're using it, the viewing angle, I mean, the camera doesn't do it quite as much justice, but the angle of viewing is very good, and the real estate on the screen is pretty sharp as well. The blue light in dark contrast environments does actually really, really work well. Lead configuration, I've got it here in the amp at the moment, but we've got the normal, simple, common, and positive there for voltage measurements and resistance testing and everything. But then we have the 10 amp there for the current measurements. I'll do a couple of little demonstrations of these in a minute. What is also brilliant about this, and again, if you're selecting your first multimeter, it's worth spending a bit more money to go for meters like this that do auto-ranging. You'll see many multimeters, when you start to look, they'll have a dial, and there'll be dozens of different settings around the dial. And you've always got to be aware of where your settings are in case you risk damaging the instrument or getting inaccurate measurements. Testers like this that auto-ranging just kind of help eliminate that problem further on. This has got it's got an off in 2 positions, which I like, because if you're using it with one-hand operation, for example, and this is not right in front of you, you just want a way to turn it off quite sharply. You go all the way to the left or all the way to the right until the dial actually stops moving, and then you know it's in the off position. It does have an auto power off function anyway, but it's just easy, because I believe probably the biggest steep competitor to this would be the Fluke 11.7. That one, the off isn't all the way up. There's another dial beyond that, which I think is this one, the low impedance voltage. Low impedance voltage, which gives this display back on now. So let's say you're measuring a voltage measurement and you've isolated a circuit. Let's say you're working on a two-way switching arrangement, and you've just obviously checking the voltage at the light switch position and verifying it's isolated, and you measure a voltage and you're not sure where that's coming from. This is what we would probably call a ghost or a stray voltage, where a voltage has been induced due to the length and the capacitive components of the system. The way to remove that is to get a multimeter like this that has this voltage low Z, or voltage low impedance setting. So if you measure a voltage just on a normal voltage setting, a ghost voltage may appear. It could be anything from a few volts even to 10s, 20s, 30s, even 100 volts, depending on obviously the induced amount of voltage on that dead cable. You go down to slow impedance voltage, however, and it should give you a true isolated or true value of the voltage on that conductor. So that's a very important thing for electricians to have. We've got the voltage, again, auto-ranging between AC and DC as well. We have the frequency measurement. I'll go through the ranges of this, but I believe off the top of my head that the frequency for this is... Actually, I can't remember what is on the box. It is 600 Hertz to 60 kilohertz. Okay, with a 0.1 Hertz to 10 Hertz resolution. Okay, so I mean, that's far beyond what we would probably need as electricians. We have the ohm scale here, so we have this for continuity, resistance measurements, resistor measurements, but you can also just use it for the simple audible beep. There's a couple of options there for the audible tone, the diode testing, or the resistance as well. I'll demonstrate all these functions soon. Microfarads, measuring capacitors, the capacitance of capacitors. This actually comes up immediately as nanofarads. Again, it's auto-ranging. So you can measure nanofarads, you can measure microfarads. Pretty sweet. Now, this meter, unlike the equivalent Fluke 11.7, this has a temperature measurement, which for me is a huge gain, because I do thermal imaging and I do other fire inspections, and the temperature or the operating temperature of equipment is important when I do EICRs and if I was to do any inspections. So this one, and I'm saying this one, the 5273, this comes with temperature measurements. And let me just look at the box. And alright, the 5273, this one, and the 5277 have temperature measurement. Okay, so if you are considering the need for temperature measurement, then do make sure you pick the right model. To me, that's worth the little expenditure. I think you know this is probably around £50 to £60 more than the equivalent Fluke, but that temperature measurement alone is enough to justify that for me, really, along with just the color and the actual real estate of the screen. With regards to the screen, it has 2 times 6,000 counts, which means when you come to measure a voltage or anything, you'll have 6,000 count display here, but there's also another 6,000 count display down there. Which again, just more information, more data is excellent. Then we have amps over here. Amps is the last one. Again, auto-ranging between AC and DC. And in that case, we're going to then pop this one over here. And this is something, any good multimeter will have this requirement, where you're going to have to, for amp measurement, move the probe over to here. The risk with this is that amp measurement is basically turning your multimeter into a very short impedance. And when you measure amps, you're measuring it in series, which means this will potentially connect in the circuit as the load, and its low impedance will be the ammeter measuring the current. If I have it set to amps, but I cross it in parallel across the voltage, I'm going to short circuit it. I'm going to short circuit it if I connect this in parallel on the amp setting. And again, that's why it's important to have this separate termination here for the amps measurement. So there are some multimeters that actually, when you set amps, a shutter covers this. I mean, that's actually a very good idea, but that is not many multimeters actually do have that function. So knowledge of this is key. All right. So we've got these general buttons that are common with all these testers, really. We have mode, AC, DC, and scaling there. We have the range. To press the range, and we hold that down for the brightness of the display. Recording of the maximum and the minimum, and a hold button to hold the value. I'll just do some demonstrations of these different tests. But just before I start doing that, with regards to everything else about this instrument, it's just a good quality instrument compared to any others, really. There's nothing that actually I would say this is missing. A higher end model does come with a soft case. This does not. That would be a bonus. And also they come with this magnet holder. A lot of us now like to put these on panels, with a little magnet holder. That doesn't come included with this one. It comes with the higher end ones, but that really is kind of small fry compared to what you do get with this. All right. Category 3, Category 4 tester, Category 4 leads. The leads are rated to 15 amp as required. Good quality leads on that. Tips are there. GS30 compliance all throughout. Yeah, let's have a play and just put a couple of tests through this and just see how quickly it responds and how it auto ranges in different settings. Right, I'm going to start with a quick demonstration of the temperature measurement, and that's because my tea is going cold. So get the brightness on, take these leads out of the way. The meter comes with this K-type thermocouple. It's fairly novel, but it's exactly what you need. So put that in the instrument there. And we have the Celsius measurement at the top and the Fahrenheit at the bottom. And it's simply a occasion of just applying a contact to anything of a certain temperature, and we'll see what happens. Right. So climbing nice and gently on the outside of my cup, and then just on the inside of my cup. Yeah, my tea is getting cold. I need to drink it. So I've used this already for the hot connecting indicator video that I did. It's a very good little tool to just have a test measurement on your multimeter. So do think about, especially with like EICRs and things, do think about how many times the ability to measure an actual conductor's shielding temperature, for example. I did this with a client of mine. I mean, thermal imaging is expensive to enter, but it's a very great tool. But if you haven't got that, or if you haven't got access to that, and even when we do thermal imaging, we are supposed to calibrate our instrument, check the emissivities. And one of the best ways for me to check emissivity is to actually get a surface measurement. Okay, I don't know if you know much about thermal imaging, but we set the emissivity to determine how much a target emits thermal energy, and when we calibrate or we set the emissivity, a lot of thermometers will go with the standard 0.95 value, but to truly know the emissivity, we have to have a measured value of temperature, so we can then compare it to the camera's measured value, and then we can do a little bit of math to determine that. So little things like this are a really, really good idea and a great benefit for me. All right, well, I'm going to drink my tea, and then we will resume with the next little check. Okay, so I've got the meter now connected for testing, and I'm just next to a board that's got some resistors, some capacitors, and a little motor connected to a power supply. And the power supply has a steady voltage output of 25 volts, DC voltage. So I've got the multimeter right now set to voltage. It's just a simple connection across the conductors here, and we see that's a fairly quick response for a 25 volt voltage. Now, if I just try and hold these in place with one hand, and if I vary and adjust, let's just push this up to 30 volts. That's responding pretty good. Let's go down to about 12 volts. So you can see while I'm adjusting this power supply, the meter is being very responsive. So that's pretty good for accuracy and speed. Now the power supply is telling me it's 12.0 volts, but the multimeter is giving me that extra value there of 12.06. So I can see if it's leading from 12.0 or 12.01 from 12.0 or 12.1. I can see which way it's leading with this multimeter, which is really nice. All right, so we look at the. Let's go to the ohms. So ohms. We've got a simple continuity test on this, so I put the tips together. No beeping. That's nice. It's nice that it doesn't make a load of annoying noise straight away. But we can obviously tell it to with a little press of the mode here. And now press the mode to audible, and now it's very responsive. Should you prefer that, or should you need to have that audible tone? I'm going to take that back off though, because it's a little annoying. There we go. All right, so a couple of resistors, and let's just see how accurate this are. I mean, bear in mind that these resistors are stated as 100 ohms, 270, etc., but there's always some level of tolerance. Just see how accurate these really are. So the 100 ohm. Yeah, 99-ish. 270. Then you'll notice that's, I'll go back to that 270. You'll notice the unit is in ohms. You can just see the unit there in ohms. Now, if I go up to the kilo ohm, the unit will adjust. So now it's the kiloohm unit. This is the benefit with auto-ranging. I haven't had to adjust the dial. I haven't had to change anything on this. I'm just going around different resistors, and the actual display is adjusting the scale for me. And then we go to 5 kiloohm, which might be half a meg. You never know how it will display it. Oh no, it displays it as 500 k ohms. Good. So that's for resistors. We go over to capacitors. So again, it starts off displaying nanofarad. So we've got some nanofarad capacitors here. There's 1 nanofarad, 470 nanofarad. So let's look at the 1 and see if it sticks to that 1 nanofarad display. It does, 0.991, yeah, 1 nanofarad. That's a very low amount. If I go to a higher amount, it might need to charge the capacitor to give it a reading. We'll see if it does that. Right, that's the run. So it's just got to build up a capacitance there. 470.1 nanofarads. 470 nanofarads. Nice. We go to 47 microfarads. Charge this one up a bit. And 46.0. Yeah, good. And then 100 microfarads. $97.1. So you can see how the range is actually always adjusting. This is a really good gain with these kind of multimeters. Do try to find multimeters that have fewer dials, because if you think that your tester does more by having so many different settings, if it's not auto ranging, that's just extra padding and extra nonsense you could end up getting wrong. Now, some people will prefer that accuracy, being able, dictate that. But for electricians and people that kind of just need to travel around panels, they don't want to have to keep adjusting the ranges. Auto-ranging instruments are very, very helpful for that. Okay, so we've done a voltage measurement, which we did earlier on. Let's just check that that's still there. So we've got 12 volts on this now. Obviously, the little motor here is not running because there's no supply to it. It's a broken circuit here. If we go to measure amps, we're going to need now to move this lead over here on 10 amp. So this goes up to 10 amp. Now, that's a pretty general limit for this kind of range multimeter. And other than very large, powerful machines, this is pretty much all that you would need to measure current on. If you do need to go higher, you need to have a higher spec multimeter. But this is a standard limit range, really. As I say, these test leads, I think, are only rated to 15 or so amp. Yeah, these are rated to 15 amps. So you're going to need a much more robust, rugged multimeter if you're going to go above 10 amp anyway. But this should be standard. Right, so to measure current, I need to connect this in series. I've put it to the amps. I've put it across. This is a parallel measurement. I don't want to do that. I want to go in series. So I'm going to complete the circuit now by going on the positive here, and I'm going to then carry it on to the side of the motor here. And we are measuring 0.05 of an amp, and that's at 12 volts. So if I adjust the voltage, if I increase the voltage, we should increase the current. Yeah, and if I decrease, okay. So it tracks really well. Really, really well. I really like that. Okay, so we've looked at the temperature, we've looked at the voltage, we've looked at the current and the capacitance, we've looked at the amps. I was going to make up a rig to look at the low impedance. I might add that as another video later on. I need to get some long cables to actually illustrate stray voltages. I haven't got the time to do it right now, but I will provide a bit more information about why this little setting is very useful for electricians. But overall, to conclude, I think that I'm happy with this multimeter, and I'm going to be using this multimeter a lot more moving forwards with rigs like this for apprentice content, resistance, parallel, all this stuff that you're going to be doing level 1, level 2. I've not really created much content on this before because I kind of aim content more at level 3 and above for electricians, but I do know that there is a need for this because I get asked these questions in my communities. So I'd like to thank Chauvin Arnoux for bringing this in and letting me have this. Also the power supply, which I'm going to demonstrate a lot more on as we move forwards, because it's nice, tidy, it's a bit heavy, but it's a nice, tidy, clean power supply, which combined with all this kit will provide some great resources. Cool. You'll see there's a lot more of this little meter moving forwards. Cheers. Thanks.